We know that the price elasticity of demand for a good can be measured using the formula percent change in quantity divided by the percent change in price. We also know that if we're not given these percentage changes, we can calculate the percentage changes using the two price and quantity combinations that we do know. That formula is Q2 minus Q1 divided by Q1 over P2 minus P1 divided by P1. Using this method, we can actually calculate the percentage changes in quantity and price in order to determine PED. But there's a bit of a flaw with using this method. We're going to demonstrate that now. Let's go over to our demand curve for hot dogs. We've got 2 points of the demand curve, point A and point B. Notice that at point A, the price is $4, and at point B, the price is $2. At point A, the quantity demanded is 10, and the quantity demanded at point B is 12. Let's go ahead and calculate the price elasticities of demand between points A and B, and then once again between points B and A. You might say, well, that's a pointless task because there's two different prices and two different quantities. Certainly the price elasticity of demand is going to be the same whether the price is going up or down. Let's go ahead and determine whether that's true or not. Let's start at point A, where the original quantity is 10 and the new quantity is 12. So I can calculate my percent change in quantity using the method shown on the left. 12 minus 10 divided by 10 should give me the percent change in quantity. And that's 2 over 10, which is 20%. Let's go ahead and calculate the percent change in price, and then we can calculate the price elasticity of demand between points A and B. Our original price was 4, our new price is 2. So we can do P2, that's 2, minus 4, divided by the original price of 4. That's going to give us negative 2 over 4, or negative 50%. So what is the PED when the price falls from $4 to $2? The PED between points A and B is 20% divided by 50%. That's negative 0.4. So let's go ahead and see if the same result occurs when we go from $2 to $4. When we go from point B to point A, we have a new quantity of 10 and an original quantity of 12. So we can do 10 minus 12 divided by the original quantity of 12. That's going to give us a negative 2 over 12, or negative 1/6. Let's go ahead and calculate negative 1/6. We can do 1 divided by 6. That gives us negative 0.16. We'll round that to negative 0.17, negative 17% basically. So the quantity now falls by 17%. So we have negative 17% change in the quantity. Let's go ahead and calculate the percent change in price. Our new price is $4 now. We go from point B to A, so we have a new price of 4. P2 is 4, minus P1 is 2, and divide that by P1, which is 2. That's going to give us 4 minus 2 over 2 is 1, or 100%. Let's calculate our price elasticity of demand when the price goes from $2 to $4. So the PED, when we go up in price, the price elasticity of demand equals negative 17 over 100, which is negative 0.17. All right, what do we see? When the price fell from $4 to $2, the PED was negative 0.4, but when the price went up, the PED was negative 0.17. Why do we have such different results? The reason is the magnitude of changes are much different when you go down in price than when you go up in price. When the price falls from 4 to 2, that's a 50% decrease in price. But when the price rises from 2 to 4, that's a 100% increase in price. Likewise, when the quantity increases from 10 to 12, that's a 20% increase in quantity, but when the quantity decreases from 12 to 10, that's only a 17% decrease in quantity. So is there a way we can calculate PED that cancels out these discrepancies when moving along a demand curve from higher prices to lower prices or from lower prices to higher prices? And in fact, there is. We're now going to demonstrate what's called the midpoint method for calculating PED. This uses the midpoint along the demand curve, and the average price, so the average price would be the price in the middle of the two prices that we're comparing, and the average quantity, which would be the quantity in the middle of the two quantities that we're comparing. When we use the average prices and quantities when calculating percent changes, we will get the same PED whether price increases or decreases. So the midpoint formula is as follows. We calculate the change in quantity. We still do Q2 minus Q1, but we divide that by the average quantity, which can be found by adding the two quantities. So we do Q1 plus Q2 and dividing it by 2. That will be our numerator in the PED calculation. The denominator will be the change in price, P2 minus P1, divided by the average price, which is the sum of the two prices, P1 plus P2 divided by 2. Let's demonstrate how the midpoint formula will give us the same result whether we go from A to B, and then we'll do the same calculation for B to A in our demand for hot dogs. Okay, starting with A to B, let's do the calculation now. The original quantity was 10, the new quantity, let's do that down here. The new quantity is 12, so the price elasticity of demand is 12 minus 10, that's the change in quantity, over the average quantity. What's the average of 10 and 12? Well, 10 plus 12 is 22, divide that by 2, we get 11. We're going to divide that, that's going to give us our percent change in quantity using the midpoint method, by the percent change in price. So the new price is 2, the original price is 4. We divide that by the average price, which is 2 plus 4 divided by 2, 3. Okay, that's going to give us the average change in price, whether price goes up or down. So let's do the numerator here. 12 minus 10 is 2 divided by 11. We have 2 over 11. The denominator is going to be 2 minus 4 is negative 2 over 3, negative 2 over 3. So we can do 2 divided by 11. That means there's an 18% increase in the quantity. So you could say 18%, and divide that by our percent change in price, which is negative 2/3. We know what that is. That's negative 67% when we round to the nearest hundredth. Okay, so there's our PED. Let's go ahead and solve that. 18% over negative 67%. So we just divide 18 by 0.66666 actually. And that's going to give us a PED of negative 0.27. So our PED is negative 0.27. Let's calculate the PED when the price goes up from $2 to $4 now and see if it gives us the same result. So now we've got a situation in which the new quantity is 10. So we got Q2 minus Q1 was 12 divided by the average, which is 11. And now we're going to do the new price, which is 4. The price is going up from 2 to 4, minus 2 divided by the average, which is 3. Now I've got negative 2 over 11, and we've got 2 over 3. Oh, look at this. We have the exact same thing that we did over here, except the negative signs are in the opposite places. So we're now going to have an 18% decrease. That's negative 18% in quantity, resulting from a 67% increase in price. And that's the same calculation we did here. That's going to give us a PED of negative 0.27. Check that out. We have the same PED values whether the price goes up or down. These are the same. The midpoint method for calculating price elasticity of demand uses the average prices and average quantities when calculating percent changes, meaning that we're not going to have that discrepancy that we saw when we calculated it using what we call the point method. The point method is when you use the 2 points on the graph. The midpoint method is when you use a point in the middle of those 2 points that you're comparing the changes in quantity to. So the midpoint method gives us a more accurate measure of price elasticity of demand between two prices on a graph, canceling out the differences that we'd get when raising the price or lowering the price using what we call the point method. Now, this midpoint method can be used for other types of elasticity as well. Later in this unit, you're going to be learning about cross-price elasticity of demand, income elasticity of demand, and price elasticity of supply. Using this method where we use the average quantity and the average price in our denominators when calculating percent changes in price and quantity, we're going to get a more accurate measure of elasticities of all types, whether it's cross, income, or price elasticity of demand or supply.